Illustrative Math, Geometry, Unit 1, Lesson 6 is called Construction Techniques number 4, Parallel and Perpendicular Lines. So goals today, I can construct a line perpendicular to a given line that passes through a given point not on the line. So that would be something that looks like this. Let's say let me make this line a little bit thinner. Let's say I got a given line right here, and I have a given point right here. I want to construct a line that goes through that point and is perpendicular to the line that's given to us. So that would be something like this, a line that goes through that point and perpendicular. All right, I can construct a line parallel to a given line through a given point using two different methods. So here is my given line. Here is my given point. So basically, I want to construct a line. That was what we're given right there, is this situation, and I want to construct a line that passes through that point and is parallel to the given line. So parallel, make sure you know the parallel symbols. You got arrows on the lines. It can be one arrow or a pair of arrows. That means that these two lines are parallel. That means that line M is parallel to line N. Okay? All right, so let's take a look at this warm-up. Each pair of shapes is congruent. Mentally identify a transformation or sequence of transformations that could take one shape to the other. So here's circle P. I'll do my best to trace this. So if I just basically do a translation, okay, translate circle P until P lines up with Q, okay? So I would just say here, I'm going to translate circle P until circle P aligns with circle Q. All right, over here, same idea. It's basically just going to be a translation here. So if I start out with this, really you're just going to translate it. You're just going to translate AB right there until it aligns with CD. Okay, so translate segment AB until it aligns with segment CD. Now this one here is a little harder here. So I'm going to have to, I got to get this thing turned first. So I'm going to rotate it and then translate it. So I'm going to rotate triangle DEF until it is in the same position as triangle JLK. Then translate triangle DEF. So it aligns with triangle JKL. I should have said JKL instead of JLK, because watch this here. When I rotate this thing, when I look here, F becomes L. So F and L you want in the same place. And if I look at D, D's down here. So when I rotate D, D becomes up here. So I want D and J in the same place, and then same thing with E and K. So basically those letters are named in the same order. All right, over here on this last one, if here's my ST, okay, we're gonna maybe rotate it until it's like parallel with NM and then translate it. So I'm gonna put here rotate segment ST until it is parallel to segment NM, and then translate so that they align. All right, and I really shouldn't have used arrows here. I should have used points there. Okay, so just kind of filled them in. All right, so let's get on to these construction techniques. That was basically just a little bit of review, some things that maybe you had in earlier classes. So we're going to construct a perpendicular line through a given point, not on the line. So what we want is we want a line right here that goes through A that is perpendicular to line M. So we'd have to mark it perpendicular and goes through there. Now you can't just draw it. We need to construct it. So we need to use a compass and a protractor. So let's follow these steps. Construct a circle centered at A that intersects line M. So you can really use any radius here. Just has to be big enough that it will intersect. And honestly, you really don't even need the full circle, because all we need to do is get these points here. So I'm not even going to make the full circle. I'm going to stop right there, and I'm going to label this B and this C. All right, construct a circle centered at B with radius BA, and a circle centered at C with radius CB. No, that shouldn't be CB. That should be radius AC. Or AB, either one. All right, so let me get a new compass here. Let me get a different color. Do this in blue. All right, so right there. All right, so there's my radius. I make a center here, centered at B. Right there, I'm going to keep the same radius. I make my circle right here. All right, so it says mark the lower intersection point as D. I don't have to mark the upper one because that's already labeled as A. So there's that. And then last thing, use a straight edge to construct line AD. So put your ruler right there and make your line. So here, I'll do it with a ruler. There it is. Let's do it in a different color. Make sure it's a line, so put your arrows on it. So there we go. Line AD is perpendicular to line M, okay? And I'm going to label that line AD with the arrow. So line AD perpendicular to line M, and you can mark it perpendicular, okay? All right, now we're going to construct a parallel line. So parallel to M, but through A. So the first method is to just construct two perpendicular lines. So the first thing that we're going to do is we're going to really basically just repeat what we just did, okay? So let me get a compass here. So start here with A, centered at A, opening it up big enough that it will intersect the line. Okay, so don't do this, okay, that's not big enough, okay? You need to open it up big enough that you intersect the line. You don't need the full circle. You can just stop right there once it intersects it. So I'm going to label this B and C. So next I'm going to construct a circle centered at B with radius BA. And this should not be CB. This should be BA. Okay. So here's my compass. Measure that. A little off. I'm going to move it there. Okay. So I'm, let's see, I've done step one. On step two, construct a circle centered at B with radius BA. You know what, let me change the color on that. Then I go right here, I do the same thing. I don't have to really change my compass because AC and AB are the same. Let me change that color to blue so that you can keep things organized. All right, so then there's that. And then the next step is line AD. So AD, there it is. Oh, I was supposed to label this point here as D. So there it is, line AD. Okay, so this line we know is perpendicular. Line AD is perpendicular to M. It's the same thing we just did. So now I'm going to basically construct a line perpendicular to line AD and passing through A. So I'm on, let's see, that was step 3. I'm on step 4. So construct a circle centered at A with any radius. Okay, so let me get a new color here. Let's use purple. So I'm not going to make it too big. Okay, there's that. I should say line AD. That was a typo. Line AD. Label those intersection points where a circle and line AD intersect as E and F. Okay, so then I'm going to put my compass for step 5. I'm going to put my compass at E and at F, and I'm going to make 2 circles there. Okay, so let me get rid of this. Let's get a new color. Let's go with orange. So centered at E. I just have to make it big enough that it's over half of the circle. That's probably way too big. Just a little over half. So that's probably good enough here. I really don't need the full circle. I'm just finding where they intersect. So I go to E, then I go to F, and then I connect those points. I'm going to label these as G and H, and then I just need to construct line GH. So really the good news is we didn't use any new construction techniques here because we just basically did two perpendicular lines. But at the end of this here, line GH is parallel to line M. Okay, and you can kind of tell here if you want to mark them with parallel marks. Here we go. That line is parallel to that line. Okay. All right. The other technique is by copying an angle. So here is my line. Here's my point. Step one, construct a line that passes through A and intersects M. So really any line passes through A and intersects M. Label the intersection point as B. Construct a circle of any radius centered at B. Label the points that intersect line M and line AB as C and D. Okay. So let's make our compass right here. Any radius. Okay, let's label these as C and D. All right, keep the compass the same and construct a circle with the same radius labeled at A, or centered at A, I should say. So there's that. Label the farthest point from line M as point E. Don't worry about this point, you're not going to need it. Construct a circle centered at E with radius CD. Get a new compass, I have a new color. So first I got to measure CD. So there it is. So I need to center it at E. And I don't really need the full circle. I really just need this point. All right, so label the point that intersects the circle centered at A as F. So really I just need this point here. Label that as F. And then construct line FA. So there's F. So use your straight edge. Put some arrows on it because it's a line, it's not a segment. There's that. This one, I guess I did in green. So there you go. Line AF. So there's my 2 points. Line AF is parallel to line M. Okay, remember, naming lines too. Like if I call this line AF, if I'm going to use 2 points on the line, you put arrow above it. If I have a letter on the side of it, this isn't a point here. I could say line M. Okay, so there you go. All right, so let's take a look at what we can construct. This is just a review. Circles of a certain radius, you just measure the segment and construct the circle wherever you want it. Lines and segments through 2 points. So that's just connect the points. Regular hexagon and equilateral triangles. We did that earlier in one of the earlier lessons that we did. Perpendicular bisector of a given segment. Perpendicular line through a point on a given line. So this was the last lesson. And then these two were today. Perpendicular line through a point not on the line, and a parallel line through a point not on the given line. So there we go, added this lesson. All right, last thing. Line L is the perpendicular bisector of segment PS. Unfortunately, S got lost. Use a straight edge and compass moves to construct a line perpendicular to L that goes through P, and then mark point S. So this is what we did today. So I'm going to get a compass here. So I start by making a circle any size. That's not big enough because it doesn't intersect. Just need to intersect twice. And I mark these points. And then make sure you measure this length. It should still be the same. And I make a circle here. Then I move my center to the other point that I found right there. And I mark that circle. And it should go through P. Mine's a little off, but yours will be better because you're using a sharp pencil. So there's that. So this distance is the same as this distance. You can measure it also with a compass if you want, just to verify. So if I go ahead here and measure this distance, that should be the same as that distance right there. Okay. So this point right here would be S. Okay. All right. So a little bit of review. Angle bisector. Make sure you know this vocab. It's a line that cuts an angle into two equal angles. A circle is the set of all points that are a distance r, which is the radius from the center, which is O. A conjecture is a reasonable guess that you are trying to either prove or disprove. Inscribed is a polygon that fits inside a circle with every vertex of the polygon on the circle. So when you look here, every vertex is on the circle. Okay. We say a circle is inscribed in a polygon if it fits inside the polygon and every side of the polygon is tangent. So tangent means it touches it one time. So this side touches your circle in one spot. It doesn't go through it and it doesn't miss it completely. Line segment, a set of points on a line with two endpoints. So this is segment AB. That's how we would write it. Or BA. You need 2 points and a line above it. Parallel. Really, there should be arrows on here. Parallel lines never intersect. We mark them as parallel with an arrow on the line. That means that they are parallel. Perpendicular bisector of a segment is a line through the midpoint of the segment that is perpendicular. So we know it's perpendicular because of the right angle. We know that this is the midpoint. I'll mark it as M because we have congruency marks. So AM is congruent to MB. Okay, back to our goals for today. I can construct a parallel line through a given point. I can construct a perpendicular line through a given point. And that's it for this video. So hopefully you enjoyed it. Thanks for watching, and we'll see you next time.